Okay, while it's loading up, oh, there's fine. It's right there. Before I forget, Myrna, do you want to go to the math conference in January? You're not tired yet? It's probably during school, so we have to do all the mess of school stuff. Maybe it's not. They usually put it over break. Okay. How do I present this? Okay. So why mathematical models? You might think, why is a mathematician doing this kind of work? Well, the main reason I came into this area is to look at self-report and offer another way for people to assess how much people are eating. And we built a model for that. We also used similar kind of ideas to understand aerobic exercise, and we also have done work on resistance training as well. They give you an objective view of the data when you look at things through a mathematical model. And the last thing which we use in the clinic is this body roundness calculator. So it's another way to assess body shape. That's not, when you look at a person's weight, that's one measurement of their health status. It tells you where they are now, and there's a summary of events that led to that possible weight. But you could also look at body shape. Someone could have a low weight, but not a healthful body shape. And so that's what this last part is about. It's the body roundness calculator, which we use. And let me start off with this. So if you're in biology, you probably don't know much about monitoring dietary adherence. That's what we call it in nutrition. I am a mathematician, so this was all new to me, and I was fine. So if you're not in nutrition, you will learn it. It's not that hard of an idea. It's been something that's been very elusive in nutrition. How do you assess how adherent someone is? So if you tell them, I would like you to cut back your calories by 500 calories a day, how do you know that they're sticking with that or not? You could look at their body weights and say, look, I think you should be losing more weight than this, but you're not 100% sure. And it's just like telling a student they cheated on a test. You have to be sure, before you start accusing people of things. The way it's predominantly done is you ask somebody. So there's different methods that are used. One is called the Food Frequency Questionnaire. And the NHANES protocol uses the Food Frequency Questionnaire, which is online. And I recommend downloading it. I had students actually download it and take the Food Frequency Questionnaire. It just asks you how many of the different kinds of foods you've had over a certain period. And it's one of those bubble fill things. You fill it with bubbles and it's assessed. And from that, they go to total energy intake, and they also can break down your macronutrients, what kind of nutrients you're taking in. Another method is 24-hour recall. That is exactly what it sounds like. You call somebody up and ask them how much food they've had over the last 24 hours. Then there's also the 3-day dietary record. The 3-day dietary record is a record they keep a food log basically. And I can show you an example of one, or the nutrition students here I'm sure have examples that they can share with you if you're not in nutrition. You can want to see what they look like. This guy's cell phones. In the past, a long time past, like pre-1950s, the predominant way research studies were done was in confinement. Because in confinement, you know what the person's doing. You know how active they are. There's some really terrific, beautiful studies done in complete confinement, where subjects were housed in a metabolic ward, or they were kept on a campus and they were kept in dorms. And one of the most powerful studies ever run is the Minnesota Starvation Experiment. There's, I think, 3 or 4 volumes in our library here where they measured everything on these guys, and they were housed on the University of Minnesota campus, and everything was known about them, what they were doing. And they were supervised 24/7. They were actually fed around 1,600 to 1,800 calories a day. That's a Jenny Craig diet. And if you look at these people at the end of a 24-week period, they look like concentration camp victims. So it really tells us, I always ask people, what about the Minnesota Starvation Experiment? When they say our subjects are really adhering. Really? Really? They look like concentration camp victims? Because these guys did. thing. So that's one way to kind of say if something's wrong. In the 1970s, doubly labeled water was used for the first time in humans by one of my colleagues, Dale Schaller. And what it is, it's a chemical isotope, and it measures, in the urine, you measure the elimination of deuterium and O18 in the subject over time, over a 2-week period generally. What this gives us is, it gives us the amount of carbon dioxide they've actually metabolized, but from that you can get the oxygen consumption per day. And oxygen consumption per day is related to calories burned. So 1 liter of oxygen consumed is equal to 5 calories burned. So from the urine, you can get oxygen consumption breakdown. From that, you can get how many calories they're burning through this little paradigm. And then finally, that will give you how much energy they've expended per day. If the person's weight stable, that means they step on the scale every day and they're the same amount of weight, well, their intake must equal their expenditures closely, right? So this gives you now, in free living humans, an objective way to assess their total energy intake without collecting food records. So if you want to, this is actually a good thing to look up. There's many studies since Dale Schuller's use of doubly labeled water in humans on self-report, any of the food frequency questionnaires, anything, and doubly labeled water. And as a whole, humans underreport, in general, underreport their total calories consumed, and by a lot. By a lot. And that's been done over and over and over again. And there was a few talks at Obesity Week that were saying, look, as nutrition as a science needs to be equal to physics as a science. We need to stop relying and making conclusions on this kind of data because it's really, really suspect data. So here's one of the papers written by Steve Heimsfield, where in this study they actually took individuals, he called them diet resistant. So I know everybody's heard of people like this that say, I look at a muffin and I start gaining weight, and I eat 500 calories a day. I don't know why I'm so big. So he took, I think, about 200 some women that were diet resistant, and he measured them by doubly labeled water. He also measured their resting metabolic. He did everything he could, measured it. And what he found was consistently they were vastly underreporting their calories consumed. So they were vastly underreporting it, and they were also overestimating their physical activity. So you get to see both. Adam Hoover, cool guy. So there's now new developments, not just models being used. This is a wrist-worn sensor that detects how much you move your hand to your mouth. Adam Hoover told us he would give us about 10 of these sensors next semester, and we can run a study here. I'll tell you about that study in a second, and anyone who wants to sign up to do it, it's going to be clinical work, so it's actually hands-on. But this is one way we can tell about maybe not how much they're eating, but about eating behaviors. And I would like to use this in the clinic. So if somebody's having trouble with, they say to you, well, I don't feel like I'm eating and I don't know what's happening to me, say, can we put one of these on you for the week, put down a $100 deposit, we'll return your deposit after you return the watch, and then we'll load it up and see their frequency of eating and their eating times. And maybe we would even be able to change their eating habits using those wrist-worn watches. The watch now, I don't know who saw it at Obesity Week, but it's gotten a lot smaller. They have a new prototype, so they're happy to let us use the old big watches in research studies here. And it's much cheaper. It's going to come down to $150 per watch. So that's like a monitor. I might get myself one if that's the case. I have a competitor to that wrist-worn watch. This is Edward Sasnov, who I work with. He's on a grant with me, actually. He has these throat sensors that detect eating and chewing and swallowing, and they sit on your throat. The only issue that Corby said is that women might not wear this because it's not pretty. That's why I like my Misfit Shine. It's pretty, you know. People look at it and say that's pretty. That's a dietary record. That's what they look like. So this is an example of a dietary record of someone who had the throat sensor on their throat, and you can see that at every incident of eating, you record the time of the day that you ate, and you record the food that you ate. And he logged it in time with the sensor. And then he compared what they said they were doing with what the sensor said they were doing. And this is what happened. This part here, the blue, is what the sensor's detecting. The red is what they reported. And you can see there's a lot of blue over here and there's no red. And so he did go back and ask the individual. I mean, they have no reason to lie. You know, you'll hear people say they're lying, they're cheating. There's no reason for this person to lie. They have the sensor. They know what the study's about. They're coming and going to deliver the sensor. And he asked her, do you remember what you were doing? And she said, I don't know, I think it was eating popcorn. But she said she was not chewing gum, and she said she was not swallowing water. It's after 10 o'clock at night. So it's pretty late at night. So my guess is that she filled the food record out later. Now, we have reading logs at home where I have to fill out my daughter's reading logs. I don't fill it out when she reads. You're supposed to. Yeah, I fill it out like 10 days later. Like, did you finish that book? We'll just put 30 minutes, 30 minutes, 30 minutes, you know? So I think that's probably what happened. And when I looked at this, I thought if she's a mother, nothing's happened. She's not going to remember anything after 5:30. Because you've got kids on each arm trying to juggle things and you don't have any clue of what you're doing. So it's possible to me that it's a signal that maybe there's underreporting because people are not filling out their logs the way they're supposed to because it's a huge burden on the patients. So this is Corby Martin, and this is a screenshot of the top of the counseling software that is in the clinic. So we developed a model that predicts how much weight you should lose if you were placed on a diet or an exercise intervention. It's personalized to that person. So you put in the inputs at the very top, and at the bottom, and this is what you'll be using in the clinic, at the bottom is the projected weight loss, that's the blue curve. Around it is a zone of variance. That's what we found when we tested the model against people where we knew how much they were really eating. And so that's the variance that we saw between our predictions and their actual weight. And over to the side is a little spreadsheet, and you can put in their weights, and this black curve will form. So this is a particularly compliant subject. It's very typical that you'll see these wiggles, right? In our clinic, we see the wiggles. Yeah, so those oscillations, we know why they're there. It's non-compliance, actually. So think about your life. Do you eat the same foods every day? You eat the same way every day? If my mother's in the house, I'm eating more because she's going to force me to. So I'm going to have one of these bumps up here. You know, you go out to eat. Anytime you go out to eat, you'll see one of those little bumps rise. So that's what that is, but you just ask them to keep in the zone. That's what you're going to do. And that way you don't have to collect any self-report. You don't have to ask them to keep dietary records. There's no 24-hour recall. There's just measuring them on the scale every week, putting their weight into the spreadsheet, and making sure that that weight is in the zone. If their weight is not in the zone, the colors on this actual weight will start to change. Every time they're not in the zone, they get a red. So the flag will come up. So you can actually talk to the patient with the color codes coming up. Yellow means they're going up in the zone, wrong direction. You go down in the zone. So you can start counseling them right away. And we have a multiple set of methods of what we do next if they're coming out of the zone, if they're moving away. And we want to buy some more equipment in there so that we have other ways to help them. Like the bite sensor is a good thing, because then you can use that and say, oh, we noticed you're coming up out of the zone. Would you like to wear the watch this week? We actually clinically tested this a few years ago. Corby recruited 40 obese patients. 20 of the participants received typical education that you would get in any weight loss intervention. In fact, Pennington's one of the sites where they have these great interventions. And so they're the site for Look Ahead, they're the site for diabetes prevention program. So they know how to do the typical education style where they come in weekly for weigh-ins. And so that's what they did with those 20 participants. The other 20 participants were never seen in the clinic. They got the model via smartphone, and they only got an email or a ping if their weight came out. And so when their weight came out, the interventionist on the clinical side would start to guide them back in all through the smartphone. The idea is to remove the burden on the patient. So they don't have to go anywhere, they don't have to go to group meetings, everything's kind of in the air, back and forth. And we have other things that Corby uses, like he uses something called remote food photography. So they have to take pictures of their food with their phone, and the pictures come back to the clinic. And there's another mathematician, he works with another mathematician, over there has the picture semi-automated. It tells you how many calories were in that food. We can do that here too. I mean, they could take pictures of the food, and there's websites that will give you an approximation. So it's not a bad idea. The 20 patients were guided by the math model. Remember, they were never seen in the clinic. They all lost weight, and 80% lost over 5% of their body weight in 12 weeks. That's tremendous, actually. And the average weight loss was over 9%. None of the 20 education patients lost over 5%, which is pretty typical, actually. So whatever we're doing in the clinic is more than what is usually seen in even commercial weight loss programs. We've published quite a bit on this. These are just 3 publications, but I think I have right now, this year alone, I have 13. So there's quite a bit published in this area. So where does the model come from? This is the energy balance equation. So it's not a statistical model. You have energy stored, that's the stuff, is equal to the rate of energy stored. So these are all per day. Is equal to the rate of energy intake minus the rate of energy expenditures, all in calories per day. And if you don't catch all of this, it's being recorded. I'll stick it on YouTube. This is called a differential equation, or differential, these are derivatives from calculus 1. But the idea is that if you have a kilogram of fat on your body and you lose that kilogram of fat, it has an energy content to it. This 9,500 was directly measured by, I think, Steve and Dale Schuller. They might have both been involved in that study, where they took from chemical composition of tissues, they know it's 9,500 calories per kilogram of fat mass. So everything's got to be energy. That's why these are conversion constants. So if a kilogram of fat is lost per day, how much is coming off as energy? Dale Schuller did this calculation for me. It comes out to about 1,000 calories per kilogram. And he did it for me. Remember I told you that I was freaked out when Corby said he wanted to stick the thing on patients, and I'm like, oh, we got to get these numbers right. That's when Dale stepped in and he got this number for me. So I didn't have to go to a lab. I know you might want to go to a lab, but I didn't have to go to a lab. They did that for me. What about energy expenditure? When you think of energy expenditure as being a pie chart of like your taxes, where they go, the big Social Security for us is resting metabolic rate. That's just the energy to run your internal organs. And Steve does MRIs where he's trying to calculate how much energy each organ actually expends. So he has a few papers on that. Then this is your physical activity. People think of that as their energy expenditure, but it's anywhere between 10 to 25%. It's not that large actually. The biggest part is right here. And then spontaneous activity. See, Krishna's doing spontaneous activity. She's banging her pen against there. Julia's chewing gum. Ruth is looking at her shoes. Nobody in here stark still. And if you want to see stark still, starve rangers and then let them go and do heavy physical activity. Eventually, when they sit down, they don't even blink. That's what I heard. So this is the spontaneous movements that we do. They actually total up to something at the end of the day. Then the rest is how much you, when you digest food, is thermogenesis from ingesting your food. And so those are the 4 pieces that you break down your energy expenditures into. You don't have to understand these, but each one of them, there's models that model each one of these pieces. Metabolic adaptations up in the RMR model. RMR actually goes down further than expected when you're dieting or exercising both. I know people think it's the other way around, but it's not. And when you're dieting or exercising, this goes down further than what's predicted by models. How much you eat, well, that's a direct proportion of how much you eat. You know, you eat more, you have to digest more, so you're going to burn more energy digesting that food. You can't get thin that way, though. Because it's a direct proportion of how much you eat. Physical activity, we just made the assumption that's a direct proportion of your body weight. So if I am bigger, I actually expend more to play basketball than if I'm smaller, because I have less to carry around. And so that's incorporated. And spontaneous physical activity, I'm not going to get into that. It's pretty messy. But everybody wants to see the full model. There it is. And we'll go away from it very quickly. We did validate it. We've been validating it much, much more than this. I mean, this is just a quick body mass at the beginning, predicted versus actual at the end of multiple different interventions. And it's doing pretty well. It's pretty well. And we've continued that, actually. Anytime someone gives me data, I test. And it's held up. So I'm going to skip the exercise part. It's really interesting, though. When we did the energy balance analysis on exercise, that's when we found that people don't increase their metabolic energy when they exercise. They actually decrease it. If they increase it, oh, here's the picture. This is, there's only one study where someone confined people and forced them to exercise and keep their intake the same. And that's Claude Bouchard's study in twins. And if their resting metabolic rate after they exercise was where it's supposed to be or higher, like people say you rev your metabolism, then the end dots should be higher than this line. The end dots are the reds. They're lower. So if you exercise very hard, you have metabolic adaptation. So why would people say their people's resting energy is revved when they're exercising? Well, it's because people eat more when they exercise, and their lean mass goes up. And when your lean mass goes up, your RMR goes up. So it's because you can control for one of these other pieces. You know, there's so many parts to our body. You have to, in the energy balance equation, if you move EE, EI might move too. So that's the problem. And they didn't control for the EI part. And Claude told me that this was a really hard study to do. He's like, oh, I could not let them out. They would eat. Oh, I can prove they ate too. I did the energy balance calculation. If I know from doubly labeled water their energy expenditures, and I know how much their body energy has changed, I can add those two things and get the change in energy intake. And this was 13 people that were measured by Klaus Westerter. So I took his data, and look, people ate like a pasta dinner more a day. But on their dietary records, nothing changed from baseline. They all said they were eating the same amounts in baseline. And when I first talked to Klaus about this, I said, are you sure? And he goes, oh, yes, they ate more. But then I did this calculation, like, okay, they did. Okay, last part. Body mass index, where does it come from? In body mass index, we assume the human body's a cylinder because that height squared, the formula for volume of a cylinder is pi r squared h. The r squared is the height squared. So the assumption is that you are a cylinder. But I took a look at my body and it's not quite a cylinder. I'm a little bit more of an egg. So what we did is we took instead the human body and we encompassed it with an ellipse, or as little kids say, an oval, right? I'm more of an egg shape. I've got these hips that come out. And you can use for the minor axis of that ellipse, you can use the waist circumference, the diameter of the waist circumference. You can actually calculate this, calculate that diameter if you know the waist circumference, and you assume that this is a circle. I can also do the same with hip circumference. So we have a hip circumference model and a waist circumference model. So what's nice about this is it takes into account people's different body shapes. You could have a really tall person and a muscular person and a pudgy person, and all three could have the same BMI. And in fact, all three of these have a BMI of 27 kilograms to meter squared. So all of them have the same body mass index, but they have very different shapes. And what you can do is you can normalize the three shapes using that ellipse. And you'll get, in fact, that this guy is the blue here, and this guy is the muscular guy in the center, and this guy is where he's supposed to be. He's the pudgy. So all three of them are delineated and separated by using this idea of roundness. So in ellipses, did everybody take pre-calc? There's this part of pre-calc where you talk about eccentricity of an ellipse. And it's really how round it is. It actually was developed by Kepler to look at orbits of bodies and going around, like the moon going around the Earth, for example. Is that a circular orbit or is it elliptical? Elliptical is bad, right? Because then you can get crashing of different objects. So he wanted a way to calculate how round that orbit is. And that number is eccentricity. The closer that number is to 0, the more round you are, and the closer that number is to 1, the more straight you are. But I applied it to the human body. And I took data and I developed some models. So what we did with those models is we said, everybody's got around this number. I can actually calculate that number by you giving me some data. Get me your waist circumference, get me your hip circumference. I can put them into this calculator, and it will give me this little round thing right here. If you're outside of the green, you're in the unhealthy zone, and your object is to move into the healthy zone. So a lot of times you can get that with just walking or exercise. So it's not about diet, it's a measure of exercise really. And you can also be inside. We had a student here, Yasmin, who was always inside this thing. We told her we were going to put her in an overheating experiment. So that's in the clinic too, and that's something we print out for each one of the patients. Every week, we measure their waist and we see if they're in or out of the green area. And Jenny Craig did want to buy that from us, but we were upset and we didn't give it to them. So as far as I know, our clinic's the only place that's using it. This is someone who had type 2 diabetes in one of my friend's interventions, and all they did is walk. 4-month intervention, lots of walking. This is the before and this is the after. So maybe once we do the pinpricks, we can actually see the glucose levels stabilizing from just walking. Maybe I'll show you something really cool. Eric Ravison, Dipna Gallagher, they're all here. Here. I don't know if you can see these, but these are testimonials from Jenny Craig clients. They love the calculators. I don't know how the patients like it in the clinic, but they love it because it's objective. You're not telling them anything. They're just either in or out of the zone, and the object is to get back in the zone. So there isn't the usual griping about, the counselor's not working with me, or it's very objective and it tells people where they need to be.